On today's Retro Tech Repair, we're going to be trying to fix this Galaxy Invader 10,000 that I bought spares or repair on eBay. So here is our Galaxy Invader 10,000. It's not in great condition, unfortunately. There is something rattling around in it. That doesn't sound terribly promising. Let's take a look at the eBay listing for this and then we'll slide some batteries in it. So it turns out I don't have the whole eBay listing since I bought this back in January this year, but here it is, the summary: the CGL Galaxy Invader 10,000 early 1980s home electronic gaming. I paid £10.25 with free shipping. Oh dear. That's not too promising. Let's turn it off. And you turn it on and it makes a hideous squealing noise. And the display is completely blank. Well, it's something different. Let's take a look what's going on inside here. Well, there's a screw missing. In fact, there's two screws missing. That's not a great sign. Clearly somebody's already been in here. Although they didn't seem to attend to whatever might be rattling around in there. And the top looks like it just lifts off. And you see the battery compartment, nice lid there. Getter compound is intact on the VFD display. It's a vacuum fluorescent display. So as you'll know if you've watched the channel before, I'm not an expert in these repairs. And with this one, I don't really know where to start, so I'm just going to start by testing components. But before we do that, I'll just bring my microphone a little bit closer and we'll take a listen one more time. As you can see, the display isn't working, and just in case there's any doubt, we'll just dim the lights here and you can see that there's nothing on the display. Alright, well, I think we've seen or heard enough of that. So since I have no experience repairing this particular game, I've no firm ideas where to look when I'm trying to diagnose this problem, and also there's no schematics or circuit diagrams available online that I could see for it, so I'm going to have to take you through the fault finding process that I would follow, and I've got a couple of new toys that I'm going to use as we go through that. So I'm not an expert in electronics. The tools that I use could be the wrong ones for the job. The conclusions that I come to could be the wrong conclusions. This is just the way that I've gone about repairing this particular game, and I thought it'd be interesting to share it with you. So I typically start with a visual inspection of the board using a magnifier, and then I'll test power and connections, and then components, starting with diodes, and then transistors, and then capacitors, and finally resistors. And this is just the order in which I've found it to be the most efficient to test things. Now, most of these are probably tested better out of the board, but we'll test them in situ first and see if we can get a feel for it. So I have done a visual inspection of the board using my magnifier here, just like a 10 times magnifier loop. I didn't see anything, but we might revisit that at some future point. But for now, I didn't see anything when I did the visual inspection, so we're going to call that one done. Power and connections. Well, a common failure on these types of things are kind of corroded connections like this, but this is the power jack. Sometimes they kind of stick open and so there's no flow from the battery to the game, but since the game was making sounds when we first tied it on, we know that isn't a problem, and a quick look on the board didn't show any problems with burnt cut tracks or anything like that, so we might revisit power and connections, but for now we're going to say that's okay too. Now, as I say, ordinarily, I'd probably go on to diodes and then transistors, but I've got a new toy that I'm going to play with, and that is a in-circuit ESR capacitor tester. So we're going to do capacitors next. Now, my experience with capacitors is that generally, in these types of games, they don't tend to be a problem. If there is a problem with a capacitor on a game like this, ordinarily, you will see that the capacitor has bulged or something like that, but yeah, we'll try it anyway. Okay, so we have our list of capacitors from the board, and what I've done is I've written the max ESR value down using this chart that I got online that looks at capacitance against the voltage rating for the cap and gives you a maximum ESR. Now, it's similar to the chart that's on the front of the device here, it just has more values, it's a bit more spread out. So that's the one that I've used, and I've written them down here. So now that I have these, I can start to measure these values. So we're going to start with C1, which is 2.2 microfarads at 50 volts. And that's right here. And we're looking for a max ESR less than 4.5, and it's 2.4, so that is good. And then we'll look at C3, 33 microfarads, 16 volts, 2.0. So 33 microfarads, 16 volts, this is C3. And we're looking for a value that's less than 2 for this one. And it's 1.29, so that's good. C4, which is here. Here we're looking for a value less than 2.2. And it's 1.02, so that's good. And then finally, C5, where we're looking for a value of less than 1.2. And it's about 0.8. So our caps are good. Capacitors. All right, so we're left with resistors, transistors, and diodes. Normally, again, I'd start with diodes and transistors because that tends to be the ones that I have most problems with. But actual fact, I've got a new toy number 2, which is my new multimeter. So we're going to measure the resistance using this. So we're going to move on to resistors. Resistors probably shouldn't be measured in circuit, so it's possible that a number of these will have parts in parallel with them and it's going to affect the readings. But we'll try it anyway, and we'll at least identify those that we know to be good. All right, so the good thing about this is they're already marked on the board. I'm just going to go through them in no particular order here, just as they come to me. So let's have a look here. R7 is marked at 82K, but is measuring 67, so there's a little bit of a question mark around that one. R6 is the same, it's measuring 67, but it marked at 82, so a little question mark around that one. Let's do R5, marked at 5.6K, and measured at 5.6K. That was R5, so that is good. And then R4, is marked at 27 ohms and is measuring around 27 ohms, so that is also good. There isn't an R1 and R2, they're probably under here. R3, marked at 3.3K. I'm measuring 3.3K. So that just leaves R8. Which measures at 66 and is supposed to be 82. So kind of like the other ones, R6, 7, and 8 are a little bit questionable, but honestly, resistors seldom fail in this kind of circuit in my experience. There's no kind of obvious trauma to them, so my suspicion is that they're good, they just got parts in parallel with them. As I say, normally they'd be lower down the list. So for now, we're going to say that the resistors are good, which leaves transistors and diodes. Let's do the diodes next. So for our diodes, we have D1 through D5, ZD1 and ZD2, and they should have about 0.7 of a voltage drop in one direction and no conductivity in the other direction. Even the Zenas, they're marked on here at 10.4 and 5 volts, so there shouldn't be enough from this meter to trip the Zener voltage and get conductivity in the other direction. So we should be looking at about 0.7 or 0.8 in one direction and then nothing in the other. So we'll start with D1, and that's interesting, 2.4. So in one direction, 0.6, which is about what we'd expect, and then in the other, 2.5. So a little bit of a question mark about D1. Probably it's got one of these other parts in series with it. Let's try D2. D2 has 0.6 in one direction and nothing in the other, so D2 is good. D3, 0.6 in one direction and nothing in the other, so D3 is good. D4 over here, 0.6 in one direction, nothing in the other, so D4 is good. D5 over here, 0.6 in one direction and then 1.5 in the other. 0.6 and then 1.5, so a little bit of a question mark about D5. ZD1 or ZD1, 0.7 in one direction, 0.25 in the other, so a little bit of a question mark around that. And then ZD2, is 0.6 or 0.7 in one direction and nothing in the other. So that's good. So then all that's left now are our transistors, and I test the transistors again on a diode test. So we've two transistors here, TR2 and TR1. So again, the type of transistor they are is marked on the board. TR1 is a C536 and TR2 is a D612. So from what I can find online, our transistor is a NPN transistor. As I've spoken about before, the NPN transistor is basically two diodes back to back. So we test it with diode test as we would a diode. Obviously it's got 3 pins. So the meter on diode test, I'm going to put the P, that's the positive in our NPN, onto our base, and then check conductivity to the emitter and the collector. And they both show about 0.6, which is great, or 0.7. Now I'm going to swap them around and try them the other way, and I expect to see nothing here. But look, I'm seeing 2.5 volts again. Now, this is a new meter. Is this just a quirk of the meter, or am I unlucky that I'm seeing all these voltage drops on these reverse bias components? I'm not sure. Let's put a question mark next to our TR1. Okay, and then the next transistor is TR2. It's a D612, so I'll look that up too. So I looked up the D612 datasheet, and that also is an NPN transistor. So we'll put our positive probe there, and we see 0.6 of a volt drop to that pin, but not to the emitter, which is not what I expected to see. Again, that is a suspect part 2. So we have quite a few suspect parts to check out now. I'm going to unsolder some of these and try them in my component tester and outside of the board. So I lifted one leg of each of the suspect diodes, that's D1, D5 and ZD1, and when I measure them out of circuit using my diode tester, 0.6 of a volt in one direction, nothing in the other, 0.6 in one direction, nothing in the other, and then this one, 0.7 in one direction, which is fine, nothing in the other. Okay, so yeah, I think those diodes are good. I can solder those back in now. I accidentally unsoldered this resistor too, so I need to solder that back in as well. So now we can cross the diodes off the list, leaving us just the transistors. I think I'm going to take those out to test them. But when I measure them out of circuit, everything looks to be good. So with our D612, 0.6 of a volt voltage drop, 0.6 of a volt voltage drop, and when I switch them round and expect to see nothing, nothing is what I see. And the same on our smaller transistor. And those results are confirmed on our component tester too, which correctly sees the D612 as an NPN transistor, and the same with our other smaller transistor here. So with diodes and transistors checked off the list, there's really nowhere left to go other than back to the visual and the power and connections. So I think I'm just going to go through with a fine tip on my soldering iron now and reflow all of these connections. So if you're not bored so far, then watching me reflow hundreds of solder joints would probably do it. So let's take a look how the game performed after I'd resoldered everything. So the painful screeching has gone and it feels like the game is actually playing, but there's nothing on the display. Nonetheless, it's the most success we've had so far, so I'm going to take another look at the printed circuit board through a magnifier. So after I'd reflowed all the solder joints, I spotted a couple of broken tracks. I think they must have moved as I was trying to solder or reflow them. And so now I see them. They weren't visible before, but they're visible to the naked eye now. I'll cut in with a photo to show you. I think I'm just going to scratch away some of this kind of green, I don't know if it's conformal coat or quite what it is, expose some of the copper and see if I can bridge those. They do run from here, from the display, to the transformer here. So I'm optimistic that this is going to fix the problem. So I'm just going to scrape some of this away now with the fiberglass pencil and see if I can clean up these tracks. What I'm trying to do is just expose some of the copper so I can solder to it. I'm just going to try and see if I can put some solder on to bridge those tracks to those pins now. That's one, I think that's pretty good. And we'll try this other one over here. I think that's got the other one too. Excellent. So all we need to do now is get everything cleaned up, reassembled, and we'll see if the game works. While I'm doing that, I'd just like to thank everybody who's subscribed to the channel and everybody who leaves comments. All of the comments are amazing. I really appreciate the feedback and I read every single one. All YouTubers love subs, so if you like this kind of thing, please consider hitting subscribe. I don't put too many videos out, so you won't get pinged too often. Thanks for that. Let's see if this repair was successful. Aha! Success! And it just goes to show that you don't need fancy tools to be able to repair some of these old games. A soldering iron would have been perfectly adequate to get this game working by fixing and reflowing those failed joints. The game now works perfectly, and it is an upgrade from the previous generations of the Galaxy Invader handhelds. This game, like all of its predecessors apart from the original Galaxy Invader, has multicoloured graphics, but it has more play lanes, and together with some scrolling effects makes it an altogether more enjoyable experience and perhaps harder than some of the other versions that have gone before it. But anyway, that just about wraps it up for our Galaxy Invader 10,000. I hope you've enjoyed the video, and until next time, I'd just like to thank you so much for watching Retro Tech Repair. And off we come with the lid.